Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will introduce trigonometric ratios. So to start off, let's look at the triangles here. We have a smaller triangle and a larger triangle. So it turns out these two triangles must be similar by the AAA test. So why is that? Well, they've both got a 90-degree angle and they both have this angle here, theta, which is called our reference angle. It is common to both triangles. So the thing is, if you have two triangles and they have two pairs of equal angles, then their third pair of angles must also be equal because the angles inside any triangle add to 180. So this triangle here have the same set of angles, and so they're similar by the AAA test. Now we've learned that if two triangles are similar, then sides are in proportion. So this means, for example, that D over A is equal to E over B. Because the sides are in proportion, the ratio of the two shorter sides in each triangle will be the same as the ratio of the two middle sides. But I could easily rearrange this equation and I would get A over B is equal to D over E. That's just a little algebra there. So it turns out that if you have an angle here that's fixed, whatever it is, 30 degrees, 20 degrees, whatever, the ratio of this side to this side is the same as the ratio of this side to this side. So we call this ratio the tangent ratio, or tan ratio for short. So by similar logic, I have D over F equals A over C. That's called the sine ratio, or sin ratio for short. And similarly, E over F equals B over C. That is the cosine ratio, or cos for short. So what it means is, if we have two triangles here that are right angled, if we know the value of this, if we fix the value of this angle here, then we have sides in proportion. But more specifically, we actually have sides within the same triangle in the same proportion. So if I fix this angle and I know what this angle will be, I know what the ratio of these two sides will be. That's the tangent ratio. I know what the ratio of these two sides will be. That's the sine ratio. I know what the ratio of these two sides will be. That is the cosine ratio. And we will end up using these ratios to find unknown sides in subsequent lessons. But let's now get a little more acquainted with each of these three ratios, the sine, cos, and tan ratio. So when we talk about the sine, cos, and tan ratio, we need to be able to label our triangles appropriately. So if we have two triangles down here, theta is our reference angle. Now you already know that the hypotenuse is opposite the right angle. That occurs in any right angled triangle. So that part's easy. So we label the other two sides, other than the hypotenuse, opposite and adjacent. So opposite means facing. So this side here is facing theta. This is the opposite side, and the side next to our reference angle theta is called the adjacent. Now, if you change the position of the reference angle, the hypotenuse stays the same. It's still opposite the right angle, but the adjacent and opposite switch around. So if I put theta here instead, this is now the opposite because it's facing theta. And this side down here is the adjacent because it's next to theta. So on the previous slide, we went through three ratios: sine, cos, and tan. Sine is the ratio of the opposite side to the hypotenuse. Cos is the ratio of the adjacent side to the hypotenuse, and tan is the ratio of the opposite side to the adjacent. As I mentioned in the previous slide, if you know the value of theta, this ratio is fixed. It is determined. So if you know, for example, theta is 30 degrees, then this ratio here turns out to be a half. If theta was 30 degrees in any of these triangles, it means this side would have to be half this side. If theta is 30 degrees, this side would have to be half that side. So these three ratios are determined by the value of the reference angle. So the way you remember which ratio is which is this acronym SOHCAHTOA. You might remember it as son on holidays can always have tons of advantages, or just SOHCAHTOA. Either way you remember it is fine. So it stands for sine is opposite over hypotenuse, cos ratio is adjacent over hypotenuse, and the tan ratio is the opposite over the adjacent. So let's look at actually calculating the value of some of these ratios. So let's say we have a triangle like this. So right angled triangle, the right angle is always facing or opposite the hypotenuse, the longest side. So if this is our reference angle theta, we know 13, the longest side is the hypotenuse. We know 12 is adjacent to theta because it's next to or touching theta, and 5 is the opposite side. So what's the value of sine theta, cos theta, tan theta? Well, as we learned on the previous slide, SOHCAHTOA, S-O-H, sine is the ratio of the opposite to the hypotenuse. The opposite is 5, the hypotenuse is 13. So the sine ratio here is just 5 over 13. Ratios and fractions are pretty much the same thing. Cos ratio. So cos of theta is adjacent over hypotenuse. So it is 12 over 13. And as you also remember from the previous slide, the tan ratio, TOA, tan opposite over adjacent. So the side opposite theta over the side adjacent theta. In this triangle here, we have theta over here. So 8 is the side facing it or opposite. 15 is the side adjacent to theta. And 17, the longest side, always the side facing the right angle, it is the hypotenuse. So in this triangle, sine theta opposite over hypotenuse is 8 over 17. Cos theta adjacent over hypotenuse is 15 over 17. And tan theta opposite over adjacent is 8 over 15. All right, let's look at a slightly harder question involving these ratios now. So here we're told in a right angled triangle, cos theta is 12 over 37. We're going to use this to calculate sine theta and tan theta. So this is a worded question. It's hard to know what's going on without seeing it. So for worded questions, let's always start by drawing a diagram. So we're going to draw a right angled triangle here where the cosine ratio is 12 over 37. Doesn't really matter where you put theta, so I'm just going to put theta over here. So if this is theta, remember cos is adjacent over hypotenuse. So the side adjacent to theta is 12 and the hypotenuse is 37. So what would be this side here? Well, we can work it out using Pythagoras. So remember, for Pythagoras, to find a shorter side, square root of hypotenuse squared minus shorter side squared. If you put that on your calculator, you get 35. This side here must be 35. Pythagoras dictates that. So if cos theta is 12 over 37, sine theta will be opposite over hypotenuse. It will be 35 over 37. So what about tan theta? Well, tan, TOA in SOHCAHTOA means opposite over adjacent. This is the angle theta. Opposite over adjacent is 35 over 12. So tan theta equals 35 over 12. So you may have noticed here, sine and cos can never be more than 1. They're always proper fractions. They always have lower number on top because the opposite or adjacent side can never be more than the hypotenuse. Tan, on the other hand, can be more than 1. And that's because tan is opposite over adjacent. The opposite side can be more than the adjacent. Sometimes the opposite is more than the adjacent, sometimes it's not. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.